Hi everybody. So I'm going to spend a lot of time talking about the past as a way of understanding the present and the future. And I'm specifically going to talk about the wrong turns that we made in the 20th century. So there are a bunch of decisions that were made in the 20th century that have come to completely define what we think of as the present. But this is only one of many possible presents. If these decisions had been made in a different direction, we would have wound up with an entirely different current situation. And many of those decisions were engineering decisions. Situations where we made a decision about how we were going to use a specific technology, and after you make that decision, the rest of history then begins to flow in a different direction. So you can think of these as being places where an idea about a piece of engineering hits history, hits reality, and there are 4 or 5 different ways that it can land, and the way that it lands then dictates the future after that point. Does this sort of make sense as an analytical framework? So we're going to talk about possible futures based on possible pasts. And I'm going to go through a few of these.
Are you doing this in the relation to Back to the Future then?
Well, funny you should put it that way, because if I'd thought about it, if I didn't realize that Back to the Future Day was basically now, but if I'd called this talk "If I Had a Time Machine," it would have been a perfect fit up. So maybe we should call it that, "If I Had a Time Machine." So what I'm going to do is basically go back over some decisions that were made and paint you a picture of the world that we could have had if we'd gone in the other direction. And I think some of these are worse worlds and some of these are better worlds. And towards the end of that, I'm going to talk a bit about software and cryptography as an example of a situation where we picked basically the worst possible world, and now we've got a few years left to fix it. The first one of these decisions I want to talk about is the US decision to use the nuclear bomb in I'm trying to think when the first one was dropped. Was it 44 or 45? 45. So Hiroshima and Nagasaki were decisions that were made, right? The US government had come to the conclusion that a bomb program was possible, and they had been convinced by the physicists, most of whom, where do we want this? Is that better? They'd been convinced by the physicists, most of whom had run from Austria, Hungary, or Germany, like almost the entire bomb team are refugees from Europe, that there was the possibility of creating a nuclear bomb, that Hitler was working on creating it, that if the Allies didn't get to the nuclear bomb first, they would lose the war to the nuclear bomb, and a very strong argument was made that this technology was not only possible, but that it was inevitable. Right. I think it was Heisenberg stays behind in Germany, and there's a very strong historical case to be made that Heisenberg stayed specifically to sabotage the Führer's nuclear bomb program. That he stayed there as the head of physics for the bomb program and took them down a whole bunch of total dead ends in a very subtle way. Whether or not that's true is an open question, but it's certainly one good reading in history. So the normal narrative that people ask about the nuclear bomb is, why did they use it in Hiroshima and Nagasaki at all? And I think that that is not the most interesting decision, right? That decision, governments are governments, they want to test the bomb they paid for. Potentially it saved a lot of American lives because they had an enormous number of prisoners of war in Japan. But that's not the question that I want to ask. The question I want to ask is, why didn't they go all the way to Moscow? Right? You've got the nuclear bomb. The Russians have taken half of Europe. They're not giving it back up anytime soon. And for a good number of years, the Americans have the nuclear bomb and the Soviets don't. And the Americans don't use the bomb. They don't threaten to use the bomb. They more or less allow the Russians to build a nuclear program without threatening to level Moscow if they even hear the word uranium. And as a result, because the Americans don't play their hand heavily when they're the only country in the world with a nuke, they allow the Soviets to catch up, and the result is mutually assured destruction. So there was a brief window in which the Americans had total world domination in the palm of their hand, and they refused to take it. They allowed the rest of the world to catch up with their nuclear agenda, and as a result, we now have a world which is completely littered with nuclear weapons, rather than a world in which there is a single global nuclear hegemon, and they have the nuke and nobody else does. Do you see what I mean now about this question of when a technology hits history, there's a branch, And the branch that we're on is the branch where the Americans refused to use the nuclear weapon, and as a result we wound up with nuclear weapons all over the world rather than a single American hegemon. This is an example of what happens when a technology hits reality and then bureaucracies make decisions relative to that technology and you get a result like the one that we're in. Now, the tough question is, what would the world be like if the Americans had decided that they were going to be the only country in the world with a nuclear bomb and they'd nuked anybody that tried to develop one? And that question, there's no way to answer. Right? So we can point to a range of potential futures in which the Americans might have made that decision in 1948, but we can't tell in those potential futures, was the world safer or unsafer, in the same way that if we lived in that world, we could speculate that if the Americans had allowed the Russians to take the bomb, then by now we would have had a nuclear holocaust and everybody would be dead. So we can only speculate about the nature of the other futures that we could have wandered into. But what I want to really focus on is this process of technology and choice, where the technology is developed by one community and the choice about how the technology will enter reality is largely made by another. The technologists develop it, or the scientists develop it, the bureaucrats and the governments and the power structures decide how it will land in reality. Does this kind of make sense? The stuff is dropped.
Today in Iraq, how does that look like?
Well, it's hard to know.
That's what the Americans finally did there.
Well, I mean, how do you mean?
Well, attack it and try to free and control the region.
Well, indeed. You know, I don't think there's been a history. I don't think there's been an empire that has fallen in the global public esteem faster than America in history. You know, if you go back 20 years, you know, there was a time when the Americans were the good guys. You know, we forget that now, but there was a time the Americans were the good guys.
When was that?
Yeah, how quickly people forget, right?
When was that?
Well, yeah, you could go as back as 6 years, but I mean, think of what was happening in Russia right the way up through the 1970s. Right? I mean, Stalin and his successors killed something like 80 million people. Is that feedback any less?
Is it too much?
Yeah, it's a bit much. So, you know, Stalin and his successors killed something like 80 million people. Mao got through about 50 million. And while that was going on, you know, the worst mass murders in history, 5 times the death toll that Hitler had, the Americans were the only thing that was containing those regimes. And they kept that up with very little support for the rest of the world from the end of World War II through to 1990, and were extremely efficient in doing it. It's very fast, you know, how quickly we forget what happened during that period of history, but that's still living memory. You know, the world moves really quickly.
I didn't actually forget that, but to me it feels like we talk about the lesser of a lot of evils. It's not that the U.S.'s hands were free of any blood at all.
Oh no, I did an
It's just
estimate.
that we keep the standard so low that they seem like the good guys compared to
Well, I mean,
bad the others. How much worse which were.
I did an estimate of this. I actually thought about that argument and worked it out on a bit of paper. And as far as I can tell, the Americans killed about 1/10 as many people as the Russians and the Chinese combined. So at the time, that made them the lesser of two evils. Now things have settled down, they look like the greater of no evils, right? You know, the times change. So let's take another example of this, which is we all have a kind of narrative about what computers are that involves transmission of information and knowledge, speeding up society, media, creation of media. Some people think of them as tools of empowerment and so on. But does everybody know where computers were invented and what they were really invented for? Right? So you could take the first inception point as being Babbage, who was an English engineer who made computers for calculating naval gunnery tables. So you wanted to fire an artillery shell and you wanted to know where it would land, and Babbage worked out this stuff on his calculating machinery. Then you come along to World War II, and the computer is invented as basically a kind of doomsday device to crack, again, German codes, so that you can make your way through the German machinery of command and win your war. And I think that we forget that the computer was born in the secret world, and that all of the cryptography we use was born in the secret world, and all of this stuff has bled out into civilian society, but it was born as weapons, and to some degree weapons it remains. The dialogue that we have in our society about cryptography is very much like the American debate around firearms. The actual kind of civilian empowerment that comes from a population that has access to strong code is very much like the empowerment of population that comes if you've got access to individual firearms ownership. We're dealing in a world where the dominant technologies that shape our societies are the spin-offs of military engineering. Nuclear weapons, nuclear power, cryptography, and computers. The internet itself was originally designed as a computer network that would be resilient in the face of a nuclear war. It was designed to connect all the nuclear bunkers and command posts together so that in the event that the bomb started falling, something would survive and you'd be able to put the pieces of the network back together again, reroute the communications, and then keep the entire show going. And I think that a lot of the problems that we're having in terms of trying to figure out where the internet fits into society comes from an inadequate awareness of the fact that this entire set of structures are essentially army surplus hardware. It's a whole bunch of things that have dribbled out of the military and out of the secret world into mass use and mass consumption. So we're constantly in a process of trying to take these formerly military technologies and put them to productive civilian use. And sometimes that's easy and it works really well, and sometimes that's extremely difficult, and we're left with this long lingering aftermath of, well, you know, have we actually gotten them free of the military background, or are they still completely embedded in it? Does this sort of make sense as a line of approach? I really want to try and get us back to the points where the critical decisions were made, and then we can move forward with the analysis from there. So, another great kind of turning point in this entire set of schemes is the 5 years around the creation of the web. So if you go back around 1990, there's a period where we've got very little access to cryptography because the really strong cryptography stuff hasn't come out yet. It's still classified or hasn't been reinvented in the civilian world, or it's been reinvented but it's not widely adopted. All the code that people are using for things like PGP and for Bitcoin and all the rest of those fundamental algorithms, what you call public key cryptography, all of that stuff has only been recently available to people. And there was an enormous civil rights struggle to take those tools and make them available that goes on all the way through the 1990s. It used to be illegal to export cryptographic code from America on the basis that that code was a weapon. And it was covered by a set of regulations called ITAR. So programmers that were interested in working those systems were often giving up their citizenship as Americans and leaving America so they could work on this stuff abroad. I can't remember whether you had to give up your citizenship, but you certainly had to leave America. So you wound up with a whole bunch of people living in tax havens, you know, working on cryptography, because if they did it from their homes in America, they would be arrested. And the regulatory framework was eventually beaten because people printed PGP out on paper and then shipped it as a book and then scanned it all back in, corrected the pages and recompiled it outside of America. Can you imagine that? And this is happening in the 1990s. This was the struggle that we went through to get people encrypted communications. And hands up everybody in the audience who's using PGP on a daily basis to encrypt their email. Ah, you see, it was basically all for nothing, right? Now should we do a show of hands for Facebook? Right? We fought very, very, very hard to make sure that these technologies remained available, to make sure that the potential of using these technologies remained present. But in actual fact, almost nobody's using them, right? I mean, you all know the world that we're in. Why aren't you encrypting your email? Right?
Because of usability and adoption.
You know, that's the excuse we make. The real answer is that people are just politically naive.
Yeah,
right?
okay, it starts with naivety.
It starts with naivety, right? I mean, we blame usability issues, but the bottom line is that people are not encrypting their email because they're not afraid enough.
Yeah.
And maybe they should be. Right? So, let's go back to these decision points. So, in the early phase, nobody realizes that the internet is going to be important. In the 1990s, and we're talking about 92 92, 91, so right around the time that you get CERN HTTPD 1.0, something like that, the very earliest phase. So in those days, there's an enormous struggle to try and figure out how to organize the internet. We've gotten as far as IP addresses, so if you want to go into a web page, you have to type in the IP address, 161.14.11.41, and you go there and you get, Alta Vista or whatever the heck it happens to be. You get your early phases of Yahoo. This is before we had domain names. Right? The only way that you could find things on the internet is people would send around spreadsheets that had lists of names and lists of IP addresses that were, the server that somebody had stood up on those names. And I still remember getting, like a weekly email that had a list of all of the sites on the internet. This is everything there is. Right? And it would be, first it was 100, then it was 300, then it was 500, then it gets to be a couple of thousand, and people think we should stick this in a database. So the database that they come up with is called domain name servers, or DNS, and we're still using the great granddaddy of or great grandchild of DNS today to organize everything. But DNS was hacked together over essentially a summer. We went from not having DNS to having DNS in practically no time at all, because people just put the pieces together in real time because something was obviously needed, and this was something, and that's what we got. So the entire hierarchical and nationalist nature of the DNS system is a direct outgrowth of a set of decisions that were made really rapidly by a bunch of people that were under pressure. So what we did was we encoded the structure of the political system of the world into the DNS system. .co.uk, .org.nl, .com just means America. Right? All of that stuff was never really properly thought through. It was a bunch of decisions that were made in a hurry by a bunch of technicians trying to solve a problem. And what they wound up doing was embedding the entire current political superstructure inside of a network that had, at the time, the potential to be genuinely global from the ground up in its conception. Right? Hurriedly made technical decisions, partitioned the internet into nationalist boundaried areas without anybody really realizing that this was a bad idea or that there was an alternative. So imagine if instead of dividing up the entire domain name system using national boundaries, they'd used something like the Dewey Decimal System. They could have just picked a different way of structuring the internet, and they could have dropped it into the system, and we would have used that instead, and nobody would have ever thought it was weird. So your websites would be divided up along the lines of a 150-year-old categorization system for books, but because that was how the internet worked, nobody would think it was weird. Right? And here's another one of these alternate histories. What if the early days of the domain name system had been organized by subject boundary rather than by national boundary? Right. .physics, .math, .history, .com. You could have had a completely different way of structuring the internet that wouldn't have given national governments an immediate appeal to power, because after all, if you've got a .uk domain name, everybody knows that that must be a site that's under the UK government's control, right? Right? And that framing of the internet as a thing that had, in some sense, national boundaries runs from basically 90, I guess it's probably 93 or 94, right up until the explosion of top-level domains that's happening right now, where people have got, .cheese and .shoe and .movie and whatever it happens to be, which are finally beginning to break up the idea that a website is predominantly defined not by its content but by its nationality. We're finally breaking the idea that the web is divided up into national groups and that the national system has America as the default nation and everything else is some kind of secondary thing that has a longer name associated with it. Right? These tiny, tiny, tiny little technical decisions wind up having an enormous impact on the way that the world works, and nobody's really paying attention to those decisions as they're made because they're typically made in a hurry by a bunch of people that are just trying to solve a problem, and as a result, the analysis that's done of those decisions is never particularly deep. We just kind of hack it together, and then we go, and if it works, and if it doesn't, it doesn't. Now, obviously, what I'm talking about between the lines here, right, in the margins, is Bitcoin and the entire blockchain revolution. So you have a bunch of systems that were hacked together in secret by a person or persons unknown who went to extraordinary lengths to defend their identity and to remain secret. And what's come out of that is a huge challenge to the idea that you need to be a nation state to issue a currency. What we have is a set of essentially law, which instead of being backed by the will of national sovereignty, instead of being backed by an army, is actually backed by mathematics. And the idea that you could back law not with a chunk of applied physics in the form of a nuclear bomb, but a chunk of applied mathematics in the form of encryption is absolutely crazy. This is one of the strangest and most exciting things ever to happen in world history. You actually have law backed by math rather than backed by guns. And I don't think anybody knows where that's going to go. It's a historic turning point that could go in one of a whole bunch of different directions, depending on what people do. Right? Imagine the reality where the Americans had gone all the way to Moscow with their nuclear bomb. Completely different universe. Imagine a world in which the internet had been non-nationalistic right from the beginning, and we'd never had domain names that divided the web up into countries. How much stronger would the intellectual defense for the internet as a global force have been if we'd never made the mistake of putting national identities into domain names? It's a terrible mistake with hindsight. Nobody really thought about it. Right? So now we're coming into all this kind of crypto range. How many implicit decisions have been made in the crypto ecosystem, in the Bitcoin and the Ethereum and all the rest of that, which are going to turn out to have wildly enormous historical impacts, but which nobody's currently aware of as a problem? Right? This is really the crux of the age that we live in. And once you realize that history is being made as a two-part process, first by the technologists and then by the politicians, kind of like a call and response or a stimulus response system, it becomes much easier to conceptualize how to steer history. The first attempt to steer history is you make a new technology. The second attempt to steer history is to try and control how the politicians mangle it as they get their hands around it. So that's the first step. I'm now going to go back to another historical turning point around an American engineer called Buckminster Fuller. So we're going to leave software, leave technology, and go back and take a look at a different model of how the 20th century could have unfolded. Has anybody heard of Buckminster Fuller? Ah, very good. So, does everybody know what a geodesic dome looks like?
What?
Geodesic dome. These big hemispheres made of pipes.
At the entrance.
Yeah, something exactly like the thing at the entrance. So, Buckminster Fuller is an American engineer who has a very, very weird spiritual awakening thing happen to him, where he, at least according to the official version of the history, decides that he's a complete failure as a human being and decides to commit suicide. And he realizes that he's throwing away a perfectly good human being, but he doesn't really want to live anymore. So he decides that he's going to throw away his personal identity and then continue to live essentially as a kind of servant of humanity. And he calls himself Guinea Pig B. What can a single human being manage if they have no self-interest, and what can they do for the world as a result of this? And Fuller certainly makes a certain amount of mythology about these decisions, but certainly went through some very, very strong and very direct personal transformation. The mythology is that he then deconstructed language by refusing to speak for 2 years, and then had to relearn English as if he was a baby. Is that true or not depends on which biography you read, but it's certainly the story that Fuller told. And his use of English appears to be as if he had learned an alien language as a native and then spoke English by translating from the alien language in his head into English. So he continues to use incredibly complex conceptual structures as single words. Omnidirectional, all space filling, universal, which to him are words that have the same kind of inherent meaning as left, right, up, down route for us. So when he says all space filling, he specifically means a structure that can be replicated without leaving gaps as it fills the entirety of the universe. By omnidirectional, he means things which expand in a kind of spherical way, and some things are omnidirectional and some things are vectors. So he divides the world up into different categories from normal English speakers. The other thing that he does is he observes the world as an outsider. So he basically says, well, clearly the point of human life is that people are supposed to be happy, and most of the unhappiness that we know how to avoid is unhappiness based on material scarcity. So why don't we just make enough of all the stuff that everybody needs to be happy, and then everybody could be happy and the problem would be solved? And he approaches this in a completely naive way. He basically looks at the entirety of history as being a failure of humanity to correctly frame the question of its existence. If the purpose of life is that people want to be happy and well, then we should just make the stuff that makes them happy and well, and we should make enough of it that everybody can have some, and then everybody will be happy and well, job's good. And he's talking about this stuff in sort of 1930s, 1940s, 1950s America as if it's the most obvious thing in the world, right? And he doesn't even really bother talking about money or how you divide up things like that. It's like, if people need denim jackets, why don't we just make 150 million denim jackets, and then anybody that wants can have one? How much is that going to cost? Like $1 a jacket? I don't know. Somebody else can figure out the money. But what he focuses on is this idea that what you have to do is you have to point the enormous power of mass production at covering people's actual needs. Right? And this was a completely radical thought, because inside of communism they had this notion that you would do this kind of mass production stuff, but you would have to have this enormous bureaucracy that held the entire show together, and there was an enormous amount of thought around the notion of central planning of everything. On the other hand, you had the capitalist system where you produced what was profitable and trusted that profitable equaled good. Hasn't gone so well. So Fuller came up with this thing which was basically a refusal to accept the limitations of thinking in either capitalism or communism. He basically said, regardless of what your political structures are, as long as you're making enough of the right things, you're going to be fine. The problem is we're not making enough of the right things, and in fact we haven't designed the right things to make. So Fuller then takes another step back and says, well, given that we've got an awful lot of people who don't have enough stuff, how do we design stuff which will allow everybody to have everything that they need cheaply enough that they can actually afford it? So he takes this step of saying, we need to figure out what the needs are for everybody, and then we need to engineer the things to fill those basic needs. So the geodesic dome was an attempt to figure out the most efficient possible house so that you could mass produce houses in factories and therefore bring the house down to a few $100s. In the same way that we mass produce cars, right? One of the great examples is, if you designed a car and built a car in the same way that you do a house, you'd have an architect for every single car, and then you'd have a succession of workmen that came around to your garage and brought the pieces with them, clipped them together into the pre-existing bits of the car that had already been assembled. The pieces wouldn't fit properly, the design would turn out to be wrong, you'd have to weld some additional bits, and it would take about 2.5 years and $50,000 before you could get even the frame in place, and your finished Mini would take like 10 years and cost like $500,000. Right? There's no way that you can produce an artifact as complicated as a car without doing industrial mass production and precision manufacturing, but we continue to make buildings essentially by hand. And the result of that is that housing is incredibly expensive, to the point where most people take 30 years of their life to pay for their housing. And that's entirely an artifact of terrible, terrible production technology. So Fuller comes along and invents the dome and basically says to the world, I've figured out how everybody can have a house for practically no money, let's just solve the housing problem and then everyone can be happy. And do you know what happens? Nothing. Right? And it's not like there's any kind of orchestrated systemic sabotage. What happens is that the human tendency to want to live in the same kind of houses that their parents lived in completely swamps people's ability to do what's good for them. Their adherence to tradition turns out to be far stronger than their ability to adapt to the circumstances that they find themselves in. And as a result, all of this astonishing creativity from Fuller winds up almost entirely without use. So Fuller's work is well known in the 1920s, 1930s, 1940s in America. It's regularly discussed in the media. He's on television. He's kind of a sort of small American national hero, maybe a bit like the Mythbusters guys are today. He does a whole bunch of very successful work for the Department of Defense on housing for troops and things like that, and they build odds and ends of it. The hippies of the 1960s are very into Fuller and geodesic domes and all the rest of that. But the basic bedrock of society never adapts to the fact that you could do incredibly high quality, low cost housing. The building codes never adapt. the regulations stay unchanged, the population doesn't buy them in any great number, and to this day they're curiosities. On the Florida coast, there are a bunch of domes that were built by Fuller and other people over the years. And when you have hurricanes, they're often the only building that's left standing for miles around. Everything else has extensive damage, and the domes are sitting there completely rock solid. And even then, people just won't build them. So somewhere inside of human culture, we have an enormous technological conservatism that means that we wind up living with terrible political problems that we could have engineered our way out of, and then we don't make the turn. And my contention is that with this, the breakthroughs that are happening right now in cryptography and computing in general, we've got another one of these historical turning points where if we have the political will, we could get to a generally safe post-scarcity society within about 2 generations and with 80% of the progress in 1. The question is, do you have the political will to change the world, to make the things that the engineers are making possible into actual political ground truths? Or is it going to be another one of these situations where the engineers put a utopian possibility in front of humanity and humanity goes back to building cubes made out of baked clay that take 30 years to pay for? Right? I mean this very, very, very seriously, because we're in a position where the choice is coming around again. Right? I worked on, basically making floors work a little bit easier to understand and a little bit easier to build. I call it the Hexier. They're being used really widely at Burning Man. There might be a few popping up here and there for refugees. We might see a bunch of them in, possibly in Europe for the European refugee crisis. We might see some adoption here. But without a broad-based political push to make these things legal to live in, what you're going to wind up is a situation where we can do incredibly cheap housing, like 2,000 euros a room for a building that will last for 200 years. Right? 200 euros a room for a building that will last for 200 years. 2,000 euros. We could get it down to 200 euros, but we'd have to do really large-scale manufacturing to do that. So what we could do is we could just say that if you live in an area where we don't need really high-density population, where you can have a certain amount of space and just kind of dot your buildings around, you could basically pay 10,000 euros for a house, and if you had a couple of kids and wanted some more space, you'd buy another couple of pods, clip them onto the side of your complex. And if your kids moved out and went to college, they could take their pods with them, fold them up, put them on top of a car, drive somewhere else, put them back up again. Right? This doesn't get you the kind of buildings that you need for like high density urban high rise, but you've got lots and lots and lots of kind of 1 or 2 story buildings all over Europe that could very easily be replaced with hexierts rather than mortgages. Right? And this is really an achievable political technology. It's a political reality. You put some solar panels on the outside, you put some water filters on the inside, you do some energy efficient cooking and heating and a few other bits and pieces. You can get a building where you just transport the building by taking the bolts out and folding it flat, and you've got kind of a car boot worth of solar panels and composting toilets and other gadgetry, and you put it all back up again, and you get basically a first world standard of living pretty much anywhere that you want to go. And all of that is completely technically possible today. Every year that passes, it gets even easier and even cheaper. Right? I've made this stuff possible. I'm not in a hurry to get people to adopt it because I think that social change is very slow, but we're in a position where it is a process of social change rather than requiring technology to change. Right? The utopian technologies are constantly around humanity, and for whatever reason, we fail to politically organize to get these utopian technologies deployed. Yes?
Has anyone tried to introduce these technologies in problems where there's like a problem with housing now? Thinking of the slums in Mumbai and Rio where there's an actual, because here it's like there's really lots of houses, so we might be kind of complacent.
Yep. So one of the reasons that I generally talk about doing this stuff here is my feeling is that if it's not good enough for rich Europeans, we probably shouldn't be inflicting it on poor Indians or poor South Americans. Right? I really want to see technologies which are good enough for the rich, and then if they scale down to the poor, that's going to be great. Like with cell phones, I'm very suspicious of technologies that want to start with the poor, because how many homeless people do you have in the Netherlands? Right? In Britain, we're knee-deep in homeless people, and we have no apparent ability to solve their problems. Right? So why don't we start with getting rid of homelessness where we are, and even if that's only a few 100,000 units, in the long run, if we prove that it works for our populations, other people can replicate. But I want to see this stuff done here first. And if South Americans or Indians come across the design and they want to build them themselves and they make those decisions, that's great. But I'm not going to go into the business of exporting my technology to people on the basis that if it's not good enough for us, maybe they want it. Right? It has to be that people deploy the technology for themselves. Otherwise, we're falling into the same trap that the NGOs fall into, and I definitely don't want to do that. Let's figure out homelessness in the places that we are first, and then from there we can kind of go on to have a think about this. So the thing that Buckminster Fuller really focuses attention on is the idea that you can have your post-scarcity society with 1970s technology. You go forward to 21st century technology, we could do a post-scarcity society without even trying. Right? We have the ability to make fabrics which last essentially forever. We have the ability to make houses out of essentially cardboard and tinfoil. We have the ability to make solar panels that are more than good enough to run your entire life on. Increasingly, the things that you use consume practically no electricity apart from heating, and the only reason you need heating is because your buildings aren't fully insulated. Right? We've got the ability to simply lift the current technological base out and live in a society in which almost all goods last forever, or at least until they tear or break, and the energy requirements for daily life are very, very, very low. But to get there, you need to stop doing old school terrible engineering, and you need to move towards doing kind of new age good engineering. And that question of where's the political will to fix the engineering, right? Can anybody think of a political party that is engineer-led and that decides that they're going to change the laws to enable good engineering to happen so the world works better?
We actually have one.
The Pirate Party.
Nuclear scientist.
Say again?
For the socialists.
Nuclear socialists?
The Dutch socialists are led by a nuclear.
The Dutch socialists are led by nuclear scientists?
Yeah.
That's amazing.
Yeah.
Rare, really rare, yeah.
Are you implying that this is a task that should be left to government?
So the technologists, the question was, is this a task that should be left to government? The technologists usually make these technologies, and then regulation stops them being deployed or changes how they're deployed. So one approach is that you go to places where there's simply no regulation and you build there, which is essentially what happened with Bitcoin, right? They went to a place with no regulation called the anonymous internet, and then they built. But the real kind of crux of this is that when you come up with technology that will really change the way things work, the first thing that happens is the state says no. Right? So a good example is electric bicycles, right? Which are very, very, very heavily and inappropriately regulated in ways which makes it very hard for people to produce the limits of what that technology allows. Right? Even in this country, I'm guessing that if your electric bicycle goes more than 15 miles an hour, you're going to wind up with some kind of weird regulatory structures around it, right? China has a huge adoption of electric bicycles because they have a regulatory framework that allows them. So what happens is that we wind up with these utopian possibilities that are then re-suppressed because the state can't figure out how to make them legal, or figures out that they're going to be bad for some monopoly or for society in general, and then takes them back out again. And this is the dynamic which is beginning to build up around the entire cryptocurrency revolution, which is currently ongoing. Right? We're at another one of these historical inflection points where truly revolutionary technological potential is being made manifest, and now we see what the response is from the forces that will either standardize it into the mainstream and it will become a part of how life is for everybody, or it will become a technological backwater like the geodesic dome. And that decision is going to be made really globally within the next 5 years, because we're going to decide whether or not processes like Bitcoin and Ethereum are fully legal instruments of a kind of global civil society, or whether they are banned and made into this underground semi-criminal kind of underworld activity. Right? Are we building the infrastructure for a single world in which it's possible for any human being to transact business with any other human being? Or are we going to balkanize and break this stuff up into a bunch of government-led bitcoins, one per currency that currently stands? Dollar coin, euro coin, yen coin. And this entire process could go either way. It's a historical choice point. I'm going to talk a little bit about what smart contracts are, and then I'm going to talk about how we're going to constitute a world court, whether it's going to be done through the UN or whether it's going to be done on the internet like normal people would do it. And then I'm going to open for questions. But I want to kind of prep the ground by saying the idea that the internet should be self-regulating and that contracts which exist only on the internet should probably have legal processes that only exist on the internet as a way of managing them is not a crazy idea. Right? If you go to all this work to create a single global computer network that reaches into every corner of planet Earth, the idea of dragging your nation-state governments along with you when you want to make decisions about how the internet governs itself should seem completely absurd. And the fact that it doesn't is only an accident of history because somebody decided that domain names should have nation-state identifiers in them. Right? That's how the state got its foothold on the internet, and if you're a young engineer, never make this mistake. So, how many people here own some Bitcoin? Okay, maybe 10%. How many people think they understand Bitcoin reasonably well? Okay, would one of you like to explain it? Right. What about smart contracts in Ethereum? Has anybody heard of a smart contract? Okay. So I'm going to give you a sort of 5-minute primer on how these things work, and then from there we can talk about what the need is for global governance around these kind of instruments. So in the beginning there is the database. 1970s technology. It's essentially a single machine with an enormous file in it, and you pour content into the file, and it all gets stored there. And you've got processes called atomic transactions, which sound much cooler than they are. So an atomic transaction is just a transaction which is indivisible in the same way that an atom was once thought to be indivisible. So maybe we should call them, I don't know, proton transactions. But anyway, so you have this indivisible transaction, which is something like update the bank account and number 1 and subtract it from bank account number 2. And that's a single unit of banking, and your database processes these units of banking, and it processes them in the order that they're received at a central hub. And that system runs the world from 1970 something to today. All the way through every institution that you deal with, somewhere in there there's a database that runs on atomic transactions, and the entire thing runs on a single access point and a queue of transactions that come in one after another. And the order in which those transactions are done is typically the order that they're arrived in, except when an American bank is going to process payments which will cause your account to become overdrawn, in which case they'll process the biggest payments first, and then they'll hit you with an overdrawn charge for every single small payment on the long tail. So they would specifically reorder the transactions to cause the maximum fee to the customer. And this is the kind of thing that happens when people mess with the natural order of reality and start reordering the transactions as they go into databases. Like, bad things happen. So when the Bitcoin guys decide that they want to build a decentralized currency, they know they're going to need a database, but there's no single point. So imagine that we've got computers scattered all over the world that are all sharing the same database. So if you send a message, the message will reach those computers at different times depending on how far away you are from the computer and how fast the computer networks are between you and them. So if we've got computer stuff scattered all over the world, and we are here and somebody else is in China, and we both do a transaction in the same instant, the machines in the world will hear about those transactions in 2 different orders depending on where they are on the globe. The machines close to China will say the Chinese transaction were first, the machines in Europe will say the European transaction was first, and the result will be that the database will split, because one part of it will say that the Chinese transaction were first and the other part of it will say the European transaction was first. And as a result, there won't be any way to keep this single global database in agreement with itself. And this is unfortunately not a problem that goes away with any level of technology short of an atomic clock. So Google, to solve this problem, put atomic clocks in all of their computer facilities, in all their data warehouses, server farms, that's the word I was looking for. So they put an atomic clock in each one, and their software understands general relativity and light speed delays. So they've created a single artificial moment called now, and all of their computers sync to that, and it takes an enormous amount of hardware and physics to make sure that that synchronization remains constant. And this is how Google solves the problem of how do you synchronize a global network. The blockchain guys didn't have the ability to put atomic clocks at every single node, so they came up with a thing called mining. And mining is essentially temporary centralization. So, in the mining process, you basically have a bunch of people who are running computers to prove how hard they are. And the guy who happens to be hardest on that round is appointed the czar, the central point for a single 10-minute window. And we call that window a block. In that block, all of the transactions that are in the block are put into an order that this guy suggests, and then that is published globally as being the next block in this thing called a blockchain. So a blockchain is a series of temporary sovereignties, one after another, that go to the person that presents the most what they call proof of work. You basically just have a computer, it goes super fast. The faster it is, the more likely you are to be appointed the next block czar. You then put together the transactions in an order that you consider good, and you put them back into the network. Any transactions that weren't in the block can be picked up by the next block, and so on and henceforth as you move forward. And this process is called a blockchain. It's subject to a thing which is called eventual consistency. So it is not apparent at any given instant whether the current block is the correct block, because somebody on the other side of the world might have made a better block or at least a different block, and there could be some delay in that reaching you because the internet cable has been hit by a shark or whatever it is. So the system has a certain amount of slack in it, where if you discover 20 minutes afterwards that there's a better block around, you can switch out your mind and decide that that block is the legitimate block. But generally speaking, within an hour or 2 hours, global consensus is reached, everything is locked down, and we agree that we've got a stable global database without having any significant centralization on the way. Did that make any sense at all, or was that arm-waving science fiction for people? Kinda, sorta is good enough, right? Just as long as you remember that the problem is that computers on the other side of the world hear about things in a different order because of the delays caused by the speed of light, and that the solution to that problem is mining, you're good. That's all you really need to know. So the first, yeah.
I have one question about this mining process. Something I never understood exactly. Okay, so you're solving a hard problem. Like the one solving the hardest problem is the one that, sort of the tsar for the moment. But like if it comes to this eventual consistency, it seems like as long as you kind of randomly appoint someone tsar for a moment, I don't get why is it so important to solve these really difficult problems in the process. Does that actually solve something else underwater, or what's going on there?
Okay, so the question is, why don't you just randomly pick somebody? The answer is that if you just randomly picked somebody, what you would get is essentially spam somebodies. So somebody makes 200 million fake users. 4 times out of 5, one of their fake users turns out to be the guy that is picked block czar, and then you wind up with that person essentially dominate the entire network because they made more fake users than anybody else. And then to get some semblance of fairness, what you wind up with is simply a competition to see who can generate more fake users. So instead of having a competition to build fake users, we have a competition to do mining problems.
So the idea is like you make something so hard that it's too hard to actually make lots of fake users.
Exactly.
That's why you need to solve the hard problem.
You solve the hard problem to stop people just making enormous numbers of fake users and then dominating the system politically by having fake users in the system.
But the problem that's solved is not actually solving anything worthwhile except for...
That's right. Yeah, the problem being solved is essentially just a proof of wasted electricity.
Right.
It's a really, really awful way of doing things. It just happens to be the thing that we figured out that worked first. So it's one of these things that was essentially a hack that turned out to work, and now we're stuck with it for another generation.
Right. Yeah, we cannot make that problem out of the SETI programming.
So the problem with problems, right? There's a whole bunch of theory around this stuff called proof of work. But if you pick up a problem which has additional uses, right? So imagine that we build a perfectly efficient system. We use the waste electricity for heating water for a swimming pool or something like that. And the problem that we're going to solve is a problem that somebody is going to solve anyway, like SETI at home or physics calculations from CERN. In that situation, we create a system where there's essentially no cost in making a fake user because all of the resources are being recaptured by the system. Right. If you're not actually sacrificing anything, there's nothing stopping you making fake users. So the more efficient your process is, the more vulnerable it is to people making fake users on it. This is, of course, completely infuriating, right? This is the worst of all possible worlds, but this is the kind of perversity of economics. We just wind up in a situation where fake users turn out to be the least bad alternative that we know of.
So you're saying if you link it to, for example, the calculations for SETI, then SETI has a reason to invest in this process and
makes a bunch of fake users in the process. Yeah, that's exactly what I'm saying. It's the kind of perversity that you always get when you're economics and rational actors inside of systems theory. It's horrendous.
There are different efforts to find useful applications, but the problem is that the solutions which have to be found for which the miners are doing their efforts, they need to be non-predictable. So I mean they are looking into this, but it's very difficult because
it's an absolute pig. Yeah. It's a really hard problem. So everybody got in their head this kind of notion of a global database, and to sequence the things in the right order, you need some kind of temporary authority, which is these czars, which are the guys that make blocks. Does that kind of sort of make sense? Because now we're going to go on to smart contracts, and smart contracts are really horrendous. So imagine that in this database, instead of storing instead of storing transactions like money, Bitcoin, instead we store programs. So suppose that I store a program in this distributed database, right? We have this global database, and I take a piece of code from my machine and I upload it, and it's spread across all of the nodes in the entire network because it's in the database. Does everybody see that would be possible? You'd wind up with hundreds of thousands of copies of some piece of code? Okay. Now, computers being computers, if you run the same program with the same inputs, you should always get the same output, right? They call this deterministic. And it's the nature of computers to be deterministic. In fact, it's really hard to get them to be anything other than deterministic, except when you're debugging software. So this deterministic system, where you take the code and you run it everywhere and it comes back with the same answer, is the foundation for programming a global sort of computer system. Same code, runs everywhere, gives you the same outputs, predictable system. So you take the kind of distributed database thing from Bitcoin, you throw it out and improve it so it goes 10 or 20 times as fast, and you call it Ethereum, and then instead of storing programs, you store code. And we call this code a smart contract. So everybody agrees on the output of the code. This is super critical. Suppose that we have a game, right? We want to play competitive tic-tac-toe on the blockchain, right? So we have the rules of noughts and crosses embedded in a smart contract, and the move that each player makes is made by writing a little an action into the blockchain, and at the end of that process we can have a global agreement about who won that game. Right? Imagine a secure, fully trusted global contest for playing tic-tac-toe. Doesn't that sound amazingly useful? Well, okay, so maybe it's a silly example, but suppose that you were doing it for something like international chess. Every single move that's made is checked into the system, one after the other. The rules of chess are embedded in the smart contract. It's impossible to make an illegal move, and everybody in the world can verify what the outcome was. Almost any system where you have direct competition between people and you need a fair set of rules can be managed by a system with a smart contract in it. What are they doing through there?
They don't agree with you, I guess.
Ah. So, inside of this sort of system, anything that you can represent as a piece of software where you want to be able to prove what the output from the piece of software is can be put into this distributed database, run everywhere in the world simultaneously, and everybody agrees on what the outputs are. Kinds of things that you might want to do that way. When you go to google.com, it'd be really nice if everybody in the world got the same google.com as a result, right? When you go to Amazon, you always want it to go to Amazon. And right now, that system is controlled through this thing called DNS, which is a hack that was made 20 years ago by a bunch of people over the course of a summer that just needed a system that worked. And they baked all these crazy assumptions into it. So what we could create would be a completely fair alternative to DNS. Provably fair, globally distributed, domain name browser, you type in a domain name, it talks to the global database, it says, where should I look for this? Comes back with the result, you go off, you go to the domain name, and then you could have a system where every year these domain names are, for example, auctioned, or maybe if you've already owned the domain name, you could continue to own it, but if you forget to pay, it becomes available. Or we could have a system where you've got to do some kind of proof of work thing, so that we could finally put an end to domain name squatting, where some idiot gets hold of your domain name and then you can never get it back again. Right? We could get into a system where your governments didn't have the ability to decide whether or not you could have a domain name. We could take a global asset, in this case domain names, and distribute them in a provably fair way to the entire world. We could do this for things like book or music publishing. Right? We could store the databases about who created human knowledge and who should get paid when a specific piece of knowledge or music is used, and we could build a single global system that managed that in a completely transparent way. There's an English artist called Imogen Heap, who turns out to have a lot of skill as a technologist, and she's sitting there basically doing the architecture for a project called Mycelia, which is an approach to doing music distribution, music rights management over a blockchain, so that everybody in the world can agree who recorded a piece of music, and all the financial agreements around the piece of music are locked into the smart contract, so they're visible to the entire world, and when you make a payment, the money is automatically sent to the people that are named in the smart contract. Does that sound like a better, fairer world? Compared to a huge number of opaque contracts locked inside of huge corporations whose lawyers specialize in making life difficult for musicians and have existed for 100 years to do just that? All of those systems are potentially in play now as things that could be replaced with transparent technology, which is open source and therefore doesn't have charges to use. Remember what I said about these historical decision points, where technology comes and opens up the potential of a better world and people either take it or they don't? So we could fix the domain name system, we could fix music. If you ask some people, they'll say that we could fix finance as well. Imagine knowing exactly who owned every single share of every company on earth, so that you could go and look at exactly what it was that was being done when these people voted to control a company. Imagine if we could track all of the world's natural resources in single global public systems that everybody agreed were provably fair, and so you could completely understand exactly who was profiting from, say, deforestation in Malaysia. All of that is within our reach, but we have to insist on the world in which these things are true, rather than being speculative possibilities like Buckminster Fuller's plan for producing enough denim jackets for the entire world. Right? Without the political will, the technologists can continue to generate utopian possibilities that humanity will simply ignore as it slides further and further and further into the gutter of history. It needs political awareness on behalf of the political radicals to understand the full implications of technology. Because if we don't have political radicalism combined with technological sophistication, we're going to wind up in a world where all of the decisions about technology are made by people that don't understand the possibilities on the table, and as a result, we'll fail to fully exploit those possibilities. So, do you have a question?
Oh yeah, I was thinking, don't you think that eventually it will become so obvious? Imagine if you could buy, for example, solar panels for like $2 and install a decentralized water collection and purification system in every neighborhood for just a fraction of what it costs now. It becomes so obvious that this is the way to go, that this political will that you speak of will just,
Yes. So
See what I'm going on?
I do. So the question is basically, when these technologies become incredibly cheap, won't they simply push the worst technology away, right? So we stop building nuclear power plants because solar is cheaper. Yes, that's absolutely true. And a lot of people talk about that. Some people use terms like market-based environmentalism. The problem is that what you'll wind up with in potential, if there is no political will, is they'll turn, 20% of the landmass of Spain into an enormous solar panel array, and then they'll charge you through the nose for your electricity and make it illegal to put solar panels on your roof, which is what they've done in Greece. Right? There's something like a €20,000 fine. Is it Greece or Spain that has the enormous fine? Spain. So in Spain, they've got something like a €20,000 fine if you're caught with solar panels on your roof.
That's exactly what I'm trying to point out, is that, for example, what we see happening right now in the United States with marijuana. It's become, the anti-marijuana politics has become, the laws have become unenforceable because people are just not willing to submit anymore.
Well, I mean, certainly in America, the kind of long process of attempting to make marijuana legal, right? How long has it taken? 100 years? 120 years?
Yeah, that's
right?
And then look at gun control.
Oh yeah, indeed, right? I mean, they still have terrible regulations on guns in America. They make it really hard to get a firearm.
Optimism, however.
Well, I'm being optimistic.
Reason on both sides.
And the fact that they've managed to keep their guns this long is an enormous victory for the Americans. But that's another story. So, because these things go together, right? If you're going to have Bitcoin, you bloody well better have a rifle. So, I was in America a really long time. So, I promised you that I was going to talk about global courts. Right? Now, this is proper radicalism, right? So let me start with the possibility. We could have global democracy just about any time we want it. And there's really no political movement globally asking for it, but the technological barriers to having global democracy are largely removed. I can't remember where I came across the critical insight, but I didn't think of it myself. Somewhere I read a very simple idea, which is that you can have global democracy based on statistical modeling. You don't need 100% of the population to vote. You need enough of the population to vote that the results are statistically significant. So if you've got, say, 60 million people voting, and you know roughly what their biases are because they live in some set of countries rather than other places on average, then you can basically model roughly how the global population would have voted if we'd had one person, one vote for the entire world. And if it's anything like 50-50, you simply decide that the answer to your question was no, but if it's overwhelming landslide support, based on the statistical modeling that you've done, you suggest the answer is yes. So Facebook right now has 1 billion users all over the world, and that's clearly enough people that you could do a statistically modeled basis for global democracy from the Facebook user base right now. Same thing is true for Google, right? And overall, we've got something like, 2.5 or 3 billion people online at the moment. That number is only going up as poor people all over the world get smartphones and get their first internet access. Pretty soon, every human adult is going to have at least basic internet. So we can move from a statistically sampled global democracy to an actual one adult, one vote global democracy within 5 or 10 years. So why is nobody asking for global democracy?
But isn't it still quite a specific demographic which has access to Facebook in comparison to the rest of the population?
So right now that is true, right? There are fewer poor people that have access to Facebook, but within 5 or 10 years it really will be everybody. These things are getting cheap really, really quickly. So if you were building the kind of statistical model of this global democracy, you'd have to take the votes of people that were poor and you'd have to give them lots of weight, because if there are only 300 people voting from a city in Bangladesh, you know that they've got views that are representative of 5 million people. In the early days, a system like that would be very imprecise. You have to then fill that stuff in with real data as you begin to get more and more people online. But the question is, right, why is there no global pressure for global democracy? Given that we've got the technological capability, right, the engineers have built the technical capability for a global democracy, why aren't we building one?
Trust.
Trust?
Trust.
You don't think we trust democracy?
We don't trust each other.
We don't trust each other.
I think we don't trust democracy either. That's what I was going to say. The democracy that we already have is completely fucked and is broken. So why do we want to build?
Why would we want a bigger one, right?
Yeah.
Possibly,
Yeah, it's
right?
like here it's bad, and Europe is worse. Don't even think about those.
Yeah, but what kind of democracy are we talking about?
Well,
Are we talking about representative elected democracy?
well,
Yeah, it's a problem, obviously.
so this is the question, right? What kind of democracy would we want if we were going to have global democracy? I wouldn't see that as immediately getting rid of our national governments. I would see it as being a level on top, right? Maybe we could have a global democracy that dealt with global issues like the environment. How are we going to manage the planetary atmosphere? That seems like a job for the entire world's people to talk about. So maybe we could have a global democracy that specifically managed climate risk, and maybe a few other global issues like, say, pandemics. So you could take the problems which the nation states have been very, very poor at solving. I think we can all agree that the national governments have basically completely failed on climate. They've done next to nothing. So we could take the areas where the current global regime is completely failing, and we could start talking about replacing it with a genuinely representative global regime made of ordinary people voting on their smartphones.
There's a danger, I'd say, like, truth is not measured in mass appeal, I'm afraid.
Yeah, I absolutely agree that truth isn't measured in mass appeal, but how are we going to run the world if not democracy?
We're not going to run the world. I think nobody should run the world.
Well, unfortunately, if nobody takes control, we're just going to continue to produce carbon to the point where we've got 6 degrees of warming and global agriculture fails.
You need a very big smart computer to control the entire.
Yeah, who programs the computer? Right? So.
Maybe there's just too much control.
I'm very skeptical of what you say about if we don't have somebody to rule that, to impose some kind of regulation on that we will just continue to produce so many carbon that will choke.
It seems to be what we've done so far. Voluntary regulation of our carbon emissions has achieved essentially nothing.
We're moving away from that, right? Slowly, maybe too slow, I don't know.
Yes, I mean, we've certainly got plenty of solar panels, right? But we've still only got something like 1% or 2% of the global energy production is renewable. Although more than half of the new energy which was installed in America in 2014 was renewable energy, it's still only a very small part of the total energy system. So even if all of the energy systems that we build now are renewable, the existing systems will still take 15 to 30 years to collapse and be replaced. So basically, in order for the world not to have something like 6 degrees of warming, we have to leave, I don't know, hundreds of billions of dollars of oil and coal and gas reserves in the ground and never take them out. And the political will to stop the people that own the oil and gas reserves mining that stuff and burning it, Saudi Arabia can produce oil for something like $2 or $3 a barrel. Renewable energy to get rid of the need for that oil is going to have to come down by a factor of 10 or 20, and we don't really have the time. Right? Renewables can compete with oil when oil is on the order of $100 a barrel, but if they begin to sell it closer to production, it's way cheaper than renewables are. Yes?
Do you know anything about carbon storing?
Carbon sequestration, right, where you just put it back into the ground. The bottom line is there are lots of people looking at different approaches. Nobody's cracked it yet. right? Lots of experiments, nothing definitive. But basically, when you pump it into the ground, it's got a really bad habit of coming back up again somewhere else.
I mean, with large-scale ecosystem rehabilitation.
Well, I mean, it's certainly possible to do it with large-scale ecosystem rehabilitation, but where's the political will?
Yeah.
But nature is kind of like solving that problem, because trees, they eat carbon.
That's unfortunately not going to help us because we're cutting down the trees far faster than they're eating the carbon. Hang on, let's go back to the smart contracts in the courts. So, the point that I'm driving towards is this, right? We have the technological possibility of doing global democracy. We've got clear failures to govern at the very highest level that threaten the entire human race, of which climate is only the most visible, and there are another half a dozen issues that are at least that large, if not larger. Nanotechnology and biotechnology regulation, I would point as being just as important as climate, they're just a little further out. So all of this blockchain technology gives you the ability to verify and validate global systems. It's the ability to audit the world. This is really what the blockchain is. It's the ability to audit the world. And if we put the right kind of political pressure on governments and corporations to make themselves fully transparent, we could audit the world, and as a result, we could get a better world. And there's a real global urgency for doing this. These smart contract things, because they're more sophisticated than just storing a transaction, because you can have some real complexity in them because there's software, potentially you could represent ecological assets in smart contracts. So you could have a sort of smart contract representation of a forest, and then every year you have somebody go out and do an assessment of the health of the forest and put the data back into the global blockchain. And with systems like that, you could get an accurate map of what the global ecological situation is. You could track the people that are cutting down the forests, and you could show where their profits are being hidden, and you could find them, recover them. So once again, what I'm basically saying is we've got a choice point. We've got a set of technologies that could potentially give us a global system of accountability which we could use to manage environmental risk. And we've got a set of technologies on the table that could potentially give us the ability to have global representative democracy on at least the global issues that are in front of us. But it's up to ordinary people to generate the political will to put these systems into production to save the world. Because otherwise, what you're going to see is another 40 or 50 years of failure of democracy to actually deliver anything resembling sensible environmental policy, and the long-term outcome will be 6 degrees of warming, the collapse of agriculture, and God only knows what kind of right-wing extremism in response to the hardships that puts humanity through. Right? The engineers can continue to make these things possible, but it requires political will to make them actual.
I have a question. Your positioning smart contracts is a way to enforce that, but isn't there the same problem? Isn't there the same enforcing problem that you say someone has to go and measure the forest, someone has to say no to a company to cut down a tree? Isn't that sort of, I say, real world measurements and consequences? They can be fraudulent and they can be not true in the terms of the contract.
Oh yeah, absolutely.
But isn't
you need
that the same as if we solve that or find a way to do that?
There are lots and lots of different approaches to that problem involving, sort of legal structures and escrow agreements or automated surveillance from things like satellites. There are lots of different ways of approaching it.
But if you would have those, automated satellites and legal is not, if it's illegal stuff, and you still need the blockchain and the smart contract to rule.
So the reason that you need the blockchains and the smart contracts is that if somebody's, this gets kind of technical, but if somebody's going out to do a survey on a patch of forest and they submit a bunch of evidence and store it in a blockchain, if you then send a second team out there and they do the survey work again and they discover the first person was lying, you know exactly who lied and you have everything that they promised on, in a completely permanent visible record. So it makes it really easy to get accountability when somebody distorts the data.
it's a global decentralized network, so there is no central authority behind it that can control that. So that once that the rules have been launched, are there, no one can stop it, no one can censor the information that's there. So if there's information that is valuable for the entire world to know, and you put it there, no one else can say, I want to hide that, or I want to take it back. Yeah. It can't be taken back.
Permanent.
That can be extremely valuable, but it also has a dark side because there might be information you don't want to get out there. People would do bad things with it and put, I don't know, plans for the atomic bomb out there for everyone to see as well. Mm-hmm. But that's exactly what it is. It's extremely valuable, but it also has a dark side as well.
Yeah. So that was basically everything I had to say about this. Thank you for listening.